Welcome back to Programming Logic and Design. In this section of Chapter 1, we'll be discussing computer systems. Now, to discuss computer systems, we need to define what the word computer means and what the word systems mean. Now, computer comes from the word computare, which is Latin, which means to count, sum up, and reckon. So kind of he does the logical decisions which needs to be done. The systems is Greek or Latin, which means a whole compounded of several parts. So it takes up a lot of different things to make up a system. So where would we find this? We find it in our hardware and our software. What is hardware? Hardware is anything you can physically touch. Okay, hardware would be a hard copy, would be a hard piece of paper. So hardware, when we talk about computer systems, will be everything we can touch, like computer screens, mouses, keyboards, your tower, your camera, etc. Software will be your things that you cannot touch. It is your processing part of your computer. It's what makes things think. It's your thinking brain, in other words. Now we get different types of software. We get our system software, which you should be familiar with, your operating system and your utilities. And you get your application software also, which is your word processing, your payroll, your inventory programs. Now, in this course, we will be focusing on your application software and the logic used to write this application software, although many other concepts apply to actually both system software and application software. Now, hardware and software both have three major operations in most programs. It's input, processing, output. We input our data items and we output our information. So we input our data items, which is whatever we're eating at that particular time. Put, we are busy digesting them and mixing them around, and we output our information on what we actually ate and the calculations, what's wrong with our body, what actually was left in our put. In our output. We have input. How do we input data? We input data through keyboard, through our mouse track movements, through talking like I'm doing right now, through images, pictures, through a pen stylus, scanning images. That will be how we input our data. Now processing is the manipulation a computer does to transform data into information. Remember, inside our little bird, it was our little put. Everything that's happening inside our bird once he eats the seeds or grains or whatever, that is what's happening. That's our processing. So what may this processing involve? It involves organizing. It involves sorting. It involves checking them for accuracy, performing calculations. That is processing. Now, what hardware component performs these types of tasks? It is our CPU, our central processing unit. It is our brain of our computer. Okay, so if you think of yourself, you take in data from looking through your eyes. You take data looking through your eyes, listening through your ears, you process it in your brain, and then what you do is you output it through your words or your hands or your actions. That is your information, how you portrayed something. I don't know if you ever played charades, but it's kind of similar to charades. You take in what you read in what needs to be done, and then you process in your brain how you're going to act it out, and that will be the information for people to read through your actions, and that's your processing. All right, output is our information. Output is everything we can see. You can output only through storage devices. You can output through your monitor, printer, speakers, and you can output through a digital interface as well. Now, programming professionals often use the term data for input items, but use the term information for data that has been processed and outputted. Okay. Sometimes you place output on storage devices such as disks or flash media. People cannot read data directly from these storage devices, but the devices hold information for later retrieval. So when you send output to a storage device, sometimes it is used later as input for another program. For example, you're inserting an image stored on external hard drive into Photoshop program that will be processed after all your editing has been done. All right, how a program is run and stored. So how do we actually write a program? You type instruction on the keyboard. So you type in some data for the computer. Then what happens to the program instruction? Tick, 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 tick. It is stored in computer memory. Now, is this computer memory temporary or permanent? Now, temporary means that it can be changed, it can be deleted. Permanent means that it is there. It's not going anywhere. All right. Now, many of your questions about computers are about memory and storage. Where are all the programs I've installed? Where are they stored? Why do I lose my work when there is a power failure? What is RAM and why will it help to buy more RAM if my computer is slow? These are some of the questions you need to ask yourself. Okay, let's chat a bit about computer memory storage. Computer memory storage is divided into volatile storage and non-volatile storage. Now, volatile storage is temporary. It is internal within the computer. Contents are lost when computer is turned off, okay, or loses power. If we think about our lovely laptops, this is our RAM. RAM is our quick access. RAM is random access memory. It stores programs currently running and data items currently being used. But what happens if you want to retrieve or modify stored instructions later? Which brings us to non-volatile storage. This is permanent and persistent storage. It's not lost due to load shedding or battery failure. System automatically saves your work at regular intervals on a non-volatile storage device. And some examples will be CDs, DVDs, external hard drives, flash drives. Now, computers can be used for many different tasks because any program can be copied from memory to storage and from storage to memory and then can be processed again. So we can copy from our non-volatile storage, place it into volatile storage, into a temporary, work on it, process it, etc., and then save it back onto our storage device. Right, programming languages. We get very many different types of programming languages. Just as some people speak English and others speak Japanese, programmers write programs in different languages. Now, some programs work exclusively in one language, like Java, and whereas others know several and use one that is best suited for the task at hand. So, what is a programming language? A computer program consists of a list of instructions in logical order, very important. Computer instruction, which is Visual Basic, C#, C++, or Java. Instructions you write using a programming language is called program code. And coding a program is writing instructions. So when you are writing instructions, you are coding a program. Now, just a fun fact about Java. Can you see that Java looks like a coffee cup with some steamer? Just a fun fact on actually how the developer of Java came up with its name. Now, it was C++ based language and it was created by James Gosling. Now, it was first named after an oak tree outside his office, OAK. Name of the new language changed to Java in a coffee shop because oak was already taken. Our programming language is governed by its own rules and word usage and punctuation. Now, the rules are called the language's syntax. Mistakes in the language's usage are called syntax errors, like at the bottom here, syntax errors. Syntax errors occurs because of misspelling or incorrect or missing characters, example, semicolons and brackets, etc. Now, your syntax must be perfect. Computers can't interpret the programming language instruction at all if it is not perfect. Computers are stupid. You are the clever one. You've got to tell them exactly what to do. All right, I want to discuss the cycle of a computer program. All right, we start with our typed instruction, which is the programmer's language's statements. We tap, 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 tap. This is stored into memory. It's translated using a compiler or interpreter software. You should be familiar with NetBeans, JGrasp. I've already gone through Notepad++. These highlight syntax errors when we compile our programs. And this is translated to machine or binary language, which the computer only understands. Remember, he's stupid. He only understands a configuration between zeros and ones, a representative series of zeros and ones. That's all he understands. He does not understand this. He's not clever enough. So binary language is represented by millions of on and off circuits within a computer, zeros and ones. And you are the one that understands this sort of language, which is Java, C++, C#, etc. So now we've translated into binary machine language. This is our source code, which is our programmer's language statements, and this is our object code. Now the program runs, it executes when there's a successful translation. And what happens is instructions are carried out. So a typical program is input, processing, and the results are outputted. So we input, we process, and once we run it, we output the results. All right, I would really like you to visit this website, learn which programming language to use. It basically just gives you a rundown on what all these programming languages actually do. If you have a look, HTML, CSS, which you'll just learn next year, allows you to create and edit web pages. JavaScript, it adds drag or drop functionality to your web pages with using HTML and CSS. Ruby, Python, PHP, are used to store information. They are like a server-side languages. Objective-C, you should be familiar with if you have an iPhone. That's usually your iPhone apps. Java, C++ are usually your Android apps. So please have a look at this website. It's good activity for you, digital engagement, and read through all of them. It will be very good for you to become familiar with all the different types of languages available for you. Remember, this course gives you a foundation in all these programming languages. To finish off, all programming languages need to be translated to machine language before it can be executed. But comprehensive programming languages like Java and C++, and we have scripting programming languages, which is Python, Lua, Perl, and PHP. Comprehensive programming languages need to be tapped into a compiler or interpreted software. Scripting programming languages need to be typed directly from the keyboard using Notepad++. Comprehensive programming languages are stored as binary executable files. Remember, zeros and ones, zeros and ones. Scripting programming languages are stored as a text. Notepad++. Comprehensive programming languages run from a compiled binary form file. Scripting programming languages interpreted line for line each time program executes. So especially for your HTTP, it interprets line for line each time the program executes. Please join me for the next video in which we will be discussing the steps involved in the program development cycle and some pseudocode statements and flowcharts.